Welcome back everyone. We can consider a new topic here, that is the Boolean Algebra. Usually our general algebra is dealing with manipulation of numbers. But here this Boolean Algebra is a branch of algebra in which the values of the variables are either true or false. The variable can take only two values, that is true or false. This true is represented using binary 1 and false is represented using binary 0. Okay. So here we have some important rules associated with this Boolean algebra. As we have already mentioned, the variables can take only two values. Binary 1 for representing high or true and binary 0 for representing low. That means false. Okay, next, complement of a variable is represented using an over bar or using this particular tilde symbol. Means if b equal to 0, then its complement is represented like this, b bar. And its value is equal to the complement of this 0, that is 1. It can also be represented like this, tilde of b. And we can also using this particular single quote symbol for representing the complement of a variable. All these are valid representation for the complement. Next, a particular operation over this Boolean variable is ORing. ORing of the variable is represented by using our plus symbol. This ORing is also known as disjunction, and we can use either this symbol or this plus symbol between the variables. Example, ORing of Boolean variables a, b and c is represented as a plus b plus c using this symbol or using this disjunction symbol. Both are valid. Next, another operation is logical ANDing operation. ANDing operation of the two or more variable is represented by writing a dot. We can use dot or this conjunction symbol for representing logical AND operation of Boolean variables. We can represent like this, A and B and C, or we can also use this particular conjunction symbol instead of this dot. Okay. And we can consider the various basic operations possible in Boolean algebra. The first one is the complementation operation. Suppose A is the variable and this particular one indicates its complemented notation. If A with value 0, then complemented operation. After this complement operation, the value become 1. If A with value 1, after complementation, its value become 0. And this is the OR operation. This defines the OR operation here. Here we have two variables A and B. Okay, and this indicate the OR operation between the Boolean variable A and B. Suppose A with value 0 and B with value 0, then after this OR operation, the result is again 0. Here it is 0, 1, then value become 1. 1, 0, after OR operation, the value is 1. If both are 1, then also value is 1. So from this table it is clear that the result of OR operation become 1 if either of these variable having a value 1. Either A or B or both are 1, then the result of this OR operation become 1. Okay, and this is the AND operation. This is simply the reverse opposite of this OR operation. Here consider the table A, B and A and B. If both are 0, then result is 0. If one is A is 0 and B is 1, again result is 0 after AND operation. A is 1, B is 0, result is 0. Both are 1, then result is 1. So in case of AND operation, from this table it is clear that if both the variable contains value 1, then only the result becomes 1. In all other three cases, the result is 0. But here in OR operation, if either of these variables contain a value 1, then result become value 1. Okay. Okay, we can consider certain laws available in Boolean algebra. The first one is the commutative law. So it can be defined like this. In case of OR operation and in case of AND operation, the order of the variables are not important. We can change the order, but the operation generate the same result. Okay, means A or B is equal to B or A. A or B generate a result which will be equal to the result generated by this variables or operation B or A. Similarly, for AND operation also, the order of the variables are not important here. We can change the order of the variables, but it generate the same result. That is commutative. Next is associative. Means A or B, then again or with another Boolean variable C. It will generate a result which will be equal to this particular operation. That is A is ORing with the result of this operation inside this bracket B or C. Okay, so this is equal to this one. Similarly for AND operation also, A and B generate a result which is AND again with another variable C. So the final result is equal to A and B and C. Okay, next is the distributive law. That means we can distribute this AND operation here. A and B or C means A and B or A and C. We can distribute this AND operation inside this bracket. Then it becomes A and B or A and C. And similarly here, this particular distribution A or B and C means A or B and A or C. So this is the distribution of this particular operation to inside of this bracket. Next is idempotent law. That is, if a variable is added with or with the same variable, then the result is A itself. And again for this AND operation, if A is AND with the same variable, then it generate the same variable. That means the value, the resultant value is equal to the value present in the variable itself. Okay, so this is the idempotent law. Next is the identity law. That means here in case of OR operation, A or 0 is A. So this 0 acts as identity. It generate while performing OR operation with 0, it generate A itself. And A and 0 is 0. And operation with 0 is 0 only. And here A or 1 is 1. And A and 1 is A. Okay, so this 1 acts as an identity value. While performing AND operation with this A, it generates A itself. And similarly here, performing OR operation with 0, it generates A itself. So this is identity law. Okay, next is the complement law. That is, A is OR with the complement of A itself. Then its value is 1. A or A complement is 1. Similarly, A and A complement is 0. Okay. Next is the involution law. So here A complement, all complement is A itself. A complement variable is complemented again, then it is equal to its original form. That is involution law. Okay, it can also be represented using this particular complement notation. Right? Next is another important law, that is the De Morgan's law. Okay, so this is complement of A or B is complement of A and complement of B. Complement of A or B is complement of A and complement of B. Similarly, complement of A and B is complement of A or complement of B. This one is a very important law Keep this in your mind. Okay, this will help you for solving very various Boolean expressions. Next is about an absorption law, that is A and A or B is A itself. Similarly, A or A and B. A and B can be simply represented like this without marking the dot operator. We can simply write AB. This indicates A and B. This again, the result is equivalent to A value. Okay. Actually, this one can be derived using our previous different laws. Consider this example. This one is the first portion of our absorption law, that is A and A or B equal to A. We need to prove it. So using the remaining laws, we can prove it. Or we can say in either way, this particular one is actually derived from the remaining laws. So consider this LHS part, A and A or B. Okay, we can apply this distributive law over here. That is A and A or B can be represented like A and A or A and B. Distribute this operator and inside this bracket. Then it become A and A or A and B. Now analyze this. A and A is A itself. That is, we can apply this idempotent law over here. From this, it is clear that A and A is A itself. Okay, now consider these two terms. Here A is common. So now we can take A outside and it become 1 A and 1 or B. Okay, again consider a variable or 1 is 1 itself. So this part become 1. That is A and 1. Okay, A and 1 is A itself. Now it is proved. That is A and A or B is A, which is proved with the help of this law. That means our absorption law is actually derived from these laws. We can consider the other part of absorption law, that is A or A and B is equal to A. We need to prove it. We can again use these other laws. First, we can apply this distributive law. That means A or A and A or B. Distribute this OR operation inside this bracket. Then it becomes A or A and A or B. Right? Then A or A means from this idempotent law, A or A is A itself. So this become A, this part become A. A and A plus B. Okay. Now here we can distribute this and inside this, or we can distribute this. We can again apply this. A and B plus C. Okay, this one comes like this, A and B plus C. So, this is A and A plus A and B. Okay, now thus, consider this. A and A is actually A itself. And this is A and B as it is. Now take this A, the common factor A outside and become A and 1 or B. 1 or B is 1 only. Then A and 1 is A itself. Hence it is proved. Okay, so it is clear that the absorption law is actually derived from these laws. Okay, thank you.